Okay, now we have this other question called valid anagram, which is kind of a famous one. So we're given two strings S and T, and we have to return true if the two strings are anagrams of each other, otherwise return false. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Example, race car and this string car race, right? Or this is a counterexample, jar jam. So basically it's the same like letters, if you will, or any type of character. So if I have like a string, I don't know, like let's say SDFG, and then here I have GT, those are anagrams of each other. Also, if I have like a point here and I don't know, a point somewhere here, those are still equivalent strings, right? Sorry, anagrams of each other. And actually, there's a space here. So yeah, now those are anagrams of each other. Anyway, I think you know what's an anagram. So there's also in this case, like the contains duplicates questions. There's a neat, super sexy, fancy, clean, and elegant trick to use here. A very common function that is forgotten for strings, and you should remember this, is the sorted function, sorted s. Now, I don't know how, in what order this, so I know this sorts the string in alphabetical order. This returns a list. So if let's say s is equal to jar, right? And then sorted s will return a list, sorry, of the characters or letters of jars sorted, right? And I think this is the right order. R comes after J, yes. So this is what happens basically. And well, I don't know if this string was like something like this. I don't know where this would come. Maybe this would come before the A, maybe after. I don't know. But anyway, the point is it sorts a string, and it will do the same for every anagram. So if you want to sort this string over here and you want to sort this string over here, the outcome will be the same array because you know the order is consistent, and we can use this sorted function on a string, which everyone forgets, to solve this exercise, right? Which is kind of cool. So the super elegant, sexy solution is you have to return sorted s equals sorted t. Because if the outcome of this sorted function called on s is the same as the outcome of the sorted function called of t, then they have the same letters basically, and basically they're anagrams of each other. To prove to you, I can run and submit. It's actually a super famous question for this problem. Super neat, clean, one-line type stuff. Now there's another solution, right, where it's like a frequency dictionary, right? So I don't know. Let's call frequency s and frequency t is equal to these two dictionaries. And the idea here is to build frequency dictionaries for s and t, where the keys are the letters or characters of each string, and the value is the amount of time this letter appears. Now, to short circuit everything, we can do something, and actually we could have used this in the previous solution as well. We have to check if the lengths are equal. So if the length of S is not equal to the length of T, you can short circuit right then and there and say there's no way they're anagrams of each other because they cannot contain the same exact letters in a different order because they don't even have the same amount of letters or characters, should I say in this case. And so if their length is not equal, you have to return false. It cannot be an anagram. Actually, we could have used this condition in the previous solution. So the first and best solution would have best, I don't know if best, but the first solution, just to be complete, should have looked something like this, right? Submit, boom, okay? This is basically a quick short circuit because if they're not even equal in length, then there's no way that they're anagrams of each other. So now that we've checked that, we've established that, okay, they have the same length, then we can loop through the indices, so to the characters of one of the letters, of one of the strings, right? So we can say for I in range, and we want to populate these frequency dictionaries with the keys as the characters and the values of the number of times they appear. And then we will compare these. So let me spoil it now. We're going to say something like return frequency S equal frequency T. Obviously, we're not saying something like is, because then we'll be referencing the dictionary objects themselves. We just want to know if they're equivalent, like if they have contain the same elements, right? Like it's like you're saying, I don't know, A, B equal A. I'm trying to make a point here that, yeah, and then here you would have said something maybe like, I don't know, list one equal So I'm just trying to show you what's by reference and versus by value, right? And you would say something like, right now, if you say list one equal list two, yes, you're right. But if you say, well, this will output true. But if you say list one is list two, no, this will output false, right? This is the difference between by reference and by value. Anyway, it's a super long tangent here. Let's not talk about this. Now we're gonna loop for I in range the length of one of the strings, right? The length s. So now I always mess this up. Am I off by one? Let's say s is equal to low, then the length is 5, and then and the index of this last letter is 4, and we're stopping at 5, so we're gonna stop at, like, the last thing we're gonna see is 4, so we're good. Frequency, how do we do this? Frequency si plus equals 1, and then here we're gonna change the t's, right? And now here we're gonna have to, so the thing is, if we're gonna get a key value error or something, because we don't have this key in this dictionary yet, but there's a there's a nice function you could use called default dict. So you import this from collections. From collections, import default dict, and then what this base default dict basically does is that if this key doesn't exist in this dictionary, it will create it with a default value depending on what you specify in default dict. So what you will specify here is int, right? Because this is the dictionary that maps to an integer. And so the default integer will be 1. Well, sorry, will be 0. Will be 1, right? So will be 1. So now we're gonna, let's say our string s is hello, right? Frequency s and I is 0. Frequency s0 is going to be h, so h plus equals 1. Well, but h is not a key in this dictionary yet because we just initialize it as a default dictionary. But since it knows that it has to add 1 to it, it's going to create the dictionary with a 1 there. It's like a smart way of handling the case where you say, if maybe you've written this before, if si in frequency s, then you do this, and then you say something like else, and then you say frequency s equals, sorry, then you would set the value, right? So equals 1. Right now, this default dicting replaces all of this. So you can write it in a more neat way, basically. Okay, this is a few tangents, but it's nice to explain the functions that I'm using. We run it, we get it, we submit it, all's good. Thank you so much. I think those are the two main ways to do it. Let's check the solutions. Yes, this is basically one, like, we're comparing the dictionaries in the end. It's basically like one of the same things that I did. This is the same thing that I did also. By the way, shout out to Neatcode because I'm learning everything from him. And this is another way, another fancy way. I don't know. You can look this on your own time. I'm not going to do this here. Thanks. See you in the next one.